everybody, this is section 6.2 in our Math to 11 Geometry textbook. And now we are going to look at parallelograms and the properties of parallelograms. Okay, so a parallelogram is a quadrilateral. It has four sides, but what makes a parallelogram is it has two pairs of, or opposite sides, both pairs of opposite sides are parallel to each other. So you have two pairs of parallel sides. Because we have two pairs of parallel sides, we do have some special properties of parallelograms. First thing we know, we have opposite sides. So, again, sides that don't share a vertex. Side AB and DC are opposite sides. But then we also we're going to talk about opposite angles. So again, they don't share a common vertex or a common side. So A and C would be opposite angles, and B and D are opposite angles as well. In a parallelogram, opposite sides of a parallelogram are congruent. So if your quadrilateral is a parallelogram, then we know that opposite sides will be congruent. So here I do know that BC is congruent to AD, and then I also know that BA is congruent to CD. While opposite sides of a parallelogram are congruent, also opposite angles are congruent. So here we have side or angle B is congruent to angle D, and then angle C and A, they are congruent to each other. So again, opposite angles are congruent. All right, now we are going to do a proof to prove that opposite angles on a parallelogram, or prove that opposite sides are congruent. So we want to prove that AB is congruent to CD and BC is congruent to DA. So we're going to start off with our statements and our reasons. I'm going to put the statements up here. And then we also have our reasons. Okay, now our given for this one. This means we are given parallelogram ABCD. So we are given, that little symbol stands for the parallelogram. So it is parallelogram ABCD. Oops, that's a 1 there, not a 2. That is our given. Okay, so now we really need to know, what do I know about parallelograms? For parallelograms, I need to, and I'm proving opposite sides are congruent. So I need to, if I have a parallelogram, you can't assume that people know this, but you have to tell us, all right, well, opposite sides are parallel. So my next step is just going to say, well, because it's a parallelogram, I know that side or segment BC is parallel to segment AD. And then I also know that BA is parallel to segment CD. And that is just going to be our definition of parallelograms. And I'll write it out. I usually abbreviate, but I can only fit that part on there, but parallelograms. Okay, now step 3. Let's see, we said opposite sides were parallel. And now this is where, again, go all the way back to chapter 3 when we were talking about parallel lines. What do I know about parallel lines? I know lots of different angle relationships. And here's what we're going to do. We are going to focus on our angles that they numbered for us. Because we have parallel lines cut by a transversal, think of this diagonal as a transversal. I now know that angle 1 is congruent to what angle? Hopefully you said 4. And I also know that angle 2 is congruent to angle 3. Now, how do we know that? If I put that on there, if I say angle 1 is congruent to angle 4 and angle 2 is congruent to angle 3, how do I know that? What do we know about parallel lines? What kind of lines are those inside the parallel lines? Hopefully, you are thinking of your alternate interior angles theorem. Okay. And then now what we're going to do, and a lot of the times you'll see this with quadrilaterals, we have that diagonal in there. We are not going to go for proving we know it's a parallelogram. The easiest way we know how to prove things is to go with our triangles. So think, I got some opposite pairs of angles congruent, but now I want you to focus. Look at this as a triangle and look here as a triangle. And I know if I look at it as two separate triangles that we have AC is congruent to AC. And that is our reflexive property of congruence. Sorry, that is horrible handwriting. And now that I have that information, I have two angles and a side. So I'm going to prove my triangles are congruent because then I can prove parts are congruent. So now I'm going to say triangle ABC is congruent to triangle CDA. And that is going to be angle, side, angle, or angle, side, angle postulate. And then the last part is nice and easy. We can say AB is congruent to CD, and BC is congruent to DA through CPC TC. So even though we left triangles, we didn't leave triangles. Even though we left parallel lines, we didn't leave them. They're all interrelated with geometry, which I kind of think is cool. I'm sure you guys do as well. All right, so here, we know the opposite angles are congruent in a polygon, but because we have those parallel lines, we also know that consecutive angles, again, are angles that share a common side. So A and D are consecutive and B and C are consecutive, or we could look at A and B and D and C. They are consecutive angles. And I want you to think about parallel lines. When you had consecutive angles, or angles on the same side of the transversal, what did you know about them? We're going to see in the next slide. Hopefully, you said, oh, I know, same side interior angles of parallel lines are supplementary. So consecutive angles in a parallelogram must be supplementary. And they are. So any pair of consecutive angles will be supplementary in a parallelogram. So A and B could be a pair of supplementary angles. B and C could be a pair of supplementary angles. C and D could be a pair of supplementary angles, or D and A could be a pair. All right, the last thing we're going to talk about with our parallelograms is going to be the diagonals of a parallelogram. And the diagonals of a parallelogram are going to bisect each other. So that means that the diagonals where they meet at a point is going to be the midpoint of both segments. It's going to cut both segments into two equal parts. Okay, so here we have a lamp, and the arms of the lamp happen to form a parallelogram. and this is parallelogram PQRS. I know that angle S is 64 degrees, and they want us to find angle P. So S and P are consecutive angles. And we just learned that consecutive angles are supplementary. So if I take 180 and I subtract 64, I should get angle P being a measure of 116 degrees. Okay, our last thing that we have here is going to be a theorem. And this theorem, it's not necessarily about parallelograms, but parallel lines. And here we're going to add in more than 2 parallel lines. So if 3 or more parallel lines cut off congruent segments on one transversal, then they're going to cut off congruent segments on every transversal. So here, because I have 3 parallel lines, and I know that this transversal right here has congruent segments between those parallel lines, that means that this transversal will also have congruent segments. It doesn't mean that BD and DF are the same measure as AC and EC, just means that BD and DF will be congruent to each other. Okay, so now what we're going to do is we're going to use parallel lines and transversals to figure out our measurements of EF and AC. So here we have in the figure AE is parallel to BF, and it's parallel to CG, and it's parallel to DH. So we have our 4 parallel lines. We also have our transversal here, 1 transversal, and I know that AB, the distance between the two, is 2. From BC, it's 2, and CD, it's 2. Because those are all the same, that means that these segments down here, whatever they are, will also be the same. And they did tell me that EF is 2.25, and they want us to find EH. So they want us to find the distance between E to H. Well, if this is 2.25, then I know FG is also 2.25, and GH is also 2.25. So I can either add them all together, or I could take my 2.25 and multiply it times 3. And I should get 6.75 units for EH. Now they also want AC. I know A to B is 2, and B to C is 2. So that means from A to C, you would add 2 plus 2, and you should get 4. And that is it for section 6.2.